So I'd like to thank everybody for joining us today. I know that conserving bandwidth isn't always as sexy as consuming more of it, 4K. So really do appreciate you coming out. I think we have a great set of panelists today. We have some panelists that represent distinct industries and technological approaches to multicast. So I'm pretty excited. We have both Comcast and Verizon here, who Chairman Wheeler will never let merge. So we may have some friction there. And then we have Ericsson and Aris, I guess, who are too big to acquire one another. So we might have a rather feisty panel today. So without further ado, I will have the panelists introduce themselves, and we'll start with Raj on my left here.
Yeah, hi, I'm Raj Nair. I'm VP of Technology of TV and Media Strategy in Ericsson, and I'm part of the Media Room team, and now we call it Media First is our new initiative, and we're got a lot of experience with multicast from several years, with IPTV from almost 10 years, and so we bring a lot of that experience into this new realm of multicast ABR.
I'm Kobe Young. I'm a Senior Director of Software Engineering at Comcast Viper. Viper stands for Video IP Engineering and Research. We're a division of Comcast responsible for building, deploying, and operating the IP video delivery infrastructure for Comcast.
Parisa Pantku, Director at Verizon, from Product Development. I'm responsible for the infrastructure build, product development, and content management of LTE broadcast, which is completely different than the multicast on the wireline side that the rest of the team will be talking about.
I'm David Grubb, CTO of Cloud Solutions at Aris. We supply technology to service providers like Verizon and Comcast and many others for video and high-speed data delivery to their consumers.
Great, thank you. So by show of hands, who here has worked with multicast or has a fairly intricate knowledge of multicast? Okay, perfect. Then this next slide should be really not very interesting to you. I have a couple of slides here to just introduce Unicast versus multicast for those who have no experience in the area, and then a slide on multicast ABR. So, you know, this is the traditional Unicast method of streaming. We've got, let's say, one video stream being replicated, or sorry, streamed 4 times down to 2 households, each with 2 receiving devices. And that's 24 megs aggregate in this case through the access network. And then we have multicast, whether it's multicast ABR, whether it's multicast of RTP streams, it is going to be replicated in a single stream through multicast and unfurled at the households into Unicast. So this is 6 megs aggregate network utilization on the access network. So what's this multicast ABR thing? How does it work? And this may just serve to confuse you. I'm sorry, but perhaps it'll get clearer as we go through this presentation, or sorry, we go through this panel. But in a multicast ABR scenario, content is segmented and moves through the network as it would traditionally. So manifest is retrieved, the CPE or COAM device is going to make that Unicast request for that segment back to the CDN. It's going to get the response. But in multicast ABR, we have a gateway or perhaps even the handset that's going to make multicast requests. So in the background in this scenario, the gateway makes a multicast request back to this multicast controller, which in turn decides to honor or deny that request. So everything continues in Unicast on top of that so that the customer gets their video streaming down. However, in the background, multicast activities take place in order to prepare that content to be put into multicast to start to get some network efficiencies. So then, once that content is available in multicast, it goes down, in this case, to the gateway and is then delivered in Unicast to that device, completely transparent to the receiving client. So I'm going to have Kobe briefly discuss the high-level architecture for Comcast, and then Parisa will sort of discuss the architecture for Verizon. Both are very distinct. Comcast using the Multicast ABR implementation, and Verizon using the RTP streamed multicast over RAN. Kobe?
Sure. We'll start at the bottom. So the client gateway is essentially a cable modem, and we have a bit of software, a multicast client running on that client gateway. When the service initializes, it reaches out to a configuration service to get its configuration, and one of those important configuration elements is the set of URL patterns that match a linear stream. And once it's initialized, it transparently inspects the HTTP traffic going through that gateway, looking for basically a pattern match on a linear stream. And when it finds that a player behind it has latched on to a linear stream, it sends a vote, and that's that popularity heartbeat message you see to a multicast controller infrastructure. When enough clients have voted on a particular linear stream, that makes that stream eligible for multicast, and the controller infrastructure reaches out to a multicast server and says, hey, this is a popular channel, we'd like to get some network efficiency by sending it out over multicast instead of relying on Unicast. The multicast server then acts as a simulated player client, grabbing content from the CDN and then pushing it out over multicast, where we're now back full circle to the client gateway, where a receiver on that client gateway takes that multicast traffic and pre-positions it in a cache so that it can transparently intercept the Unicast fragment requests from players and return them directly from cache in the gateway.
Thank you, Kobe. And Parisa, I'll advance to the next slide.
As far as on the wireless side, the term, thank you. The term, the technology is called EMBMS, and the code word at the product level is Lte Broadcast. At Verizon, we launched this platform commercialized it about a month and a half ago, early October, and the product name is Lte Multicast. Basically, it is, it has three components. It's on the RAN side, the core network elements, and then the handset. The core network elements are consistent of two boxes, which basically capture the segments from the content ingest side and translate it and pushes it out to write what we call a service area. Service area is the RAN side of Lte Multicast, and it can be basically you take a number of cell towers where you want to push that specific content. You aggregate them and let's say, for the lack of a better term, it's like a DMA. You call it, this is a DMA for this, for example, IndyCar, which is one of our commercial launched multicast applications. You take the Sonoma track, you combine the cell towers into one service area, and the core element understands that this content is going to that service area and pushes the content through this dedicated pipe, which is a guaranteed bit rate. So truly the word ABR does not apply to the Lte Multicast. And on the handset, most of the new handsets in the marketplace have the right chipset in it that understands out actually the MBMS signal. And all we need is loading a middleware into that device, which is a software push. It's integrated with the software update of the device. And then that device is capable of listening. The radio listens to the multicast signal and basically is available for the consumer to use if they choose to do so. So for the lack of a better term, just think about, the ABC News is broadcasting. If you want to watch it, you turn your TV on, you watch it. If you don't, it's broadcasting, and you just leave it alone as is.
Great, thank you. So multicast has been around for quite a long time. The failed, I don't want to say failed, but maybe M-Bone way back in the day. And RTP, RTSP streaming has been around for quite a while as well. And anyone that's done switch digital video has touched multicast or transmitted multicast within their core for video distribution for live content. So I'd like to ask each of the panelists why their company has chosen to develop or use multicast, and what were the motivating factors for that decision. And I'll start with you, Raj.
Yeah, so multicast, in our case, we've been using that for IPTV distribution for several years now, and it is really in a managed network, and and it's a TS and RTP type of workflow. The idea there was, of course, to have the best TV viewing experience and to be able to take advantage of the bandwidth savings as shown by Matt in his earlier slide, and so that we can essentially distribute, we can manage and this is in a DSL network, so we can actually manage the bandwidth carefully, and at the same time have the best viewing with the best fast channel change. We can join in like less than 250 milliseconds, so it's a experience that most of our customers have got used to, and so that's the main driving force. And right now, with ABR, we're trying to do this, retain some of those benefits while at the same time having an ABR prep. So some of the work from SCTE, like the virtual segmentation, are things that we're taking advantage of that can allow us to have both an ABR type of prep, while at the same time get the benefits of the traditional TV experience for the first screen. And so this is something that has been our motivation and how we're going forward to that.
Our primary motivation is network efficiency. So today, the cable network is split between QAM for delivering video and DOCSIS for delivering IP. We would like to have a more converged network and converging on the IP side. So in today's model where we push video content onto the QAM network, that's being placed on the network once and occupying a fixed amount of bandwidth. Once we move to an IP unicast world, unless we mitigate the strategy, each player is consuming a full amount of bandwidth for itself. And so by sort of inserting multicast in the middle, we get to sort of reclaim the shared bandwidth that we had in QAM, but in the IP world.
Great.
Sure. So you have all seen for the past few years all the analysis and studies on the growth in consumption of video over mobile handsets, and it has been proven over time how the numbers are growing. There's only a limited to David's point. There's only a limited number of bandwidth and network available. At the same time, we wanted to improve the customer experience when they want to watch a video of the best quality and not experience any freezing or buffering at the same time. So we have been also very bullish, and Verizon has been very bullish to take advantage of all the innovative and advanced technology over the LTE. So we partnered with our vendors, and when this was introduced at 3GPP about 3.5 years ago, we partnered with our vendors to drive the ecosystem and be the first company to launch that platform nationwide over our LTE network.
As has been mentioned here, really the way we see it, actually yesterday there were some presentations about consumer behavior, and as it's sort of obvious now, I think that everybody, younger generations, are moving away from the TV to other screens for watching content. So our customers who are service providers, they want to be able to deliver their video to where the consumers want to watch it. So the existing networks deliver to the TV. The new network has to deliver to the TV and to all these other devices. So there's a lot of advantages to moving to kind of a unified encoding and delivery platform for that using ABR technology. That at the same time, that has to be done at a scale that dwarfs the kinds of things that have been talked about here. I mean, if you think about, for example, in the keynote this morning, there was discussion about streaming an NFL game, and lots of work went into successfully streaming something like 7 terabits per second at peak. If you look at what it takes to deliver entertainment video to all the TVs in the US, pretty much every night of the week, the problem is about 100 times larger than that. So we have to architect a network that can solve the problem at a much different scale than works today on the internet.
Great, thanks, David. So, coming from that explanation, when you deploy a new technology like multicast ABR and even EMBMS is fairly unproven, you face a lot of challenges, right? And I'd like to ask Kobe and Parisa, what are some of the challenges you experience in during the development or deployment of your multicast platforms, and how do you address that, and how do you avoid the gotchas?
Sure. For us, I think as an engineer, I love to create lots of knobs in how to fine-tune a product. And so in the multicast delivery, there are a lot of knobs. We use technologies to make multicast reliable, which basically allows us to add some parity bits so that it's resilient to some UDP loss. So that's a knob. The number of profiles that we decide to make eligible for multicast is another knob. The size of the multicast zones is another knob. And so as we move from development into operating the system, it's the big challenge is figuring out where to fine-tune all those knobs.
Great.
For EMBMS, because it was such a new technology and 3GPP only defined a limited set of requirements for it, and Verizon, and everyone in the industry that wanted to adopt EMBMS, it was always with the notion and idea of a venue. They always talked about sports games or a venue where a large number of people want to consume the same content, and how it would apply and bring efficiency to a stadium type of environment. So Verizon, as always, not only said, okay, yeah, we're going to do it for the stadium, but also they took it a step further and decided to do it nationwide. So going from a smaller environment to let's say 50,000 plus cell towers and NOVs just created a whole new set of variables and requirements that the vendors had not thought of when they were developing their platform. So, those are the things that got us in terms of working with them closely, and based on different use cases that we're applying EMBMS to, tweak the requirements that we had specifically to apply to our use cases.
Great, thank you, Parisa. So I'll ask this of all the panelists. Do you think that there are real cost savings in deploying multicast, and are the trade-offs worth the deployment in terms of what you're going to get on your ROI? I can start with you, Raj.
Sure. I think the obvious map that you showed, is a clear indication, because you on the last mile, you do have a problem with bandwidth, and you need to be thoughtful about how you're going to use that. And so I think using multicast for distribution makes a lot of sense. And of course, having the ability at the end to unicast to the end device in the home, it's an excellent combination of the both technologies and gives maximum flexibility. And when you're outside, then of course, you're in an unmanaged network, and then what you get is you won't get the same experience, of course, but then people are used to a certain type of experience, which also you can preserve by having the ability to, let's say, cache this content and stream it using like was spoken about in the keynote today, to your endpoints that are like the pads and tablets and so on?
Yeah, I think as long as the viewing habits keep linear traffic a significant portion of the access network bandwidth, the tricks that we can do to reduce the bandwidth needs on that access network will continue to have value. I think it's a good example of adding a little bit of intelligence to the network to greatly improve efficiency.
So is it safe to say that the costs of creating that infrastructure to support multicast are significantly or substantially less than those to augment the access network?
Today, given the current linear usage patterns, yes.
Okay.
Yeah, same goes for us. I mean, network efficiency obviously is spectrum is very expensive and very limited. And as the adoption rate grows on this platform, it would save a lot of spectrum and capacity consumption. But at the same token, we don't only look at B2C, but we also look at B2B examples to use the MBMS platform. And so it's also enabling consumer to be able to receive new and innovative products, and also be very cost efficient for the enterprise solutions for the content provider.
I mean, as Kobe mentioned, it's really driven by consumer behavior. If, on Thursday night at 8 o'clock, if everybody was watching on-demand video, then there would be no opportunity to have a multicast gain, if you will. But what we see is that at 8 o'clock on Thursday night, there's still a substantial portion of the public that tunes to linear TV. So that is really what presents the opportunity. And then, as far as from a cost perspective, you asked, right? There's kind of two building blocks there that have to be considered. There's the access network. So for cable, it's DOCSIS. Or it might be a PON network or other things. But then there's also the CDN behind that. The bits, when you're doing Unicast, the bits have to get served from something. So even if you say, hey, I have a PON network, I have tons of bandwidth, well, behind the PON network, you still have to have racks of servers that are serving up those streams. So there's a benefit in cost savings on that CDN as well by effectively pushing the CDN edge into the house and then transporting the bits efficiently to that new edge point that's inside the house.
Right. Okay. Do you, this is directed at David or Raj, where do you think the sweet spot is, or the how much penetration do you really need on your IP video platform to make multicast worthwhile, or even to just see those efficiencies being realized? And I know that's perhaps not an easy question to answer without a calculator, but maybe your customers have seen something.
So when we look, we've looked at sample data from some of our other products where we can kind of look at what's being viewed. And when you look at groups of about 1,000 homes, there we see the opportunity for, I'll say it this way, 1,000 homes at 8 o'clock on Thursday night consume about 1,400 streams of video. So if you just do it brute force, I have to deliver 1,400 streams to those 1,000 homes. If you look at what they're actually watching, it's on a typical operator network, it's maybe 300 channels worth of content. So it's about a 75% savings opportunity when you look at kind of the 1,000 home level. So that's sort of one dimension, and then the other dimension is, Kobe mentioned, is, well, how's my network partitioned and what are the service group sizes? Obviously, if those 1,000 homes are spread across the whole US, you probably wouldn't have that opportunity. But in any sort of a reasonable deployment where those 1,000 homes are in the same DMA or geographic area, then there's potentially an opportunity.
Great. Yeah, I was going to add to that when you start aggregating back up, right, even in today's talk, the fact that when you have a certain request per second and it exceeds a certain threshold, then you know that you've hit the limit of how much that server can handle. So so back at the core too, so that there is a problem. So you're better off distributing this back down as far as you can, so that you can actually make something that is reasonably feasible in terms of, and of course you have to pay, you may have to pay in terms of storage on the edge, but then since if you had a way to regionalize it, you can still manage to make it work in terms of having a sweet spot between how much you distribute to the edges and what your edges are or where your regions are. And then from there, you can probably have this ability to support the Unicast, distribution. So.
Oh, great. So open source technologies, web technologies, these are all sort of converging in the household now. Handsets early on, like Android, had adopted open source software. And cable and wireless, the telcos are all sort of moving towards that space, even within their own network infrastructure, where 15 years ago, someone would have laughed at you if you wanted to set up a Linux server and have no support contract on it or something. So what do you see as the key technologies to enable multicast and multicast ABR, as well as, are there advantages in having shared or open standards for interoperability rather than, looking at how maybe cable was and the telcos were 10, 15 years ago using closed ecosystems?
Yeah, I mean, the one thing that we see is, more than even open source, we do see a need to have a cloud-based service, and this is something that we've been actively working on, and that we believe that can nicely complement the service, and so as a service offering, we see that as something that would be interesting to the market, and it could be a way to, in a sense, bridge the gap between where we are today and the need, and when standards get firmed up in this area. So,
okay.
Yeah.
So we're getting a lot of reuse from standards and open source software in our implementation. On the transport side, we're using a protocol called NORM, which stands for NAC-Oriented Reliable Multicast. This was a spec that the U.S. Naval Research Labs created to try and make UDP-based multicast solution more reliable. And so our transport is based on that. Also, the Naval Research Laboratories had provided a library that we're using to actually do the core networking. On the standard side, we're also very much aligning our implementation with the work we've done with Matt on the CableLabs side. In terms of open source software, there's several different areas where we're benefiting from that. So on the cable modem side, because this device is essentially a Linux box, it's really easy for us to add software to it and use facilities provided by Linux to help do some of the magic. So we use IP tables and Nginx in the gateway. And on the server side, we're using open source software. We're using Apache Kafka as a messaging bus to get those popularity votes into the controller infrastructure, and we're using Apache Storm as a real-time computation engine. So we're standing on the shoulders of a lot of great projects to make this work.
Anyone else can answer, or we can move on?
Yeah, just we're kind of piling on to what Kobe has really talked about there. We're leveraging, I would say in general, the philosophy has shifted, right? We're leverage open source wherever possible. And then probably just the one other comment I would make is, if you're an operator, for this to work, it has to be able to go in every gateway. So it wouldn't make sense to have a solution where you had, this kind, if I get the gateway from vendor A, then I have one network, and then if I have vendor B, I have a different network. So obviously you have to have portability of the clients across all the different gateways that exist in the network.
Okay. And my next question is really not to assimilate the Borg here and get the wireless person to be cable-centric, but David, if you were to put yourself in Parisa's shoes and look at how they're using 3GPP, EMBMS to do multicast, would you say that there's really any advantages for wireless to stream segmented video directly to handsets as opposed to using RTP streamed video?
Boy, that's a tough question. I'm not sure that there may be some opportunities there, and nothing has jumped out at me that's kind of obvious. I mean, there's some savings on the content prep side of things, but when you start to get to scale deployments, the prep piece of the equation is fairly small compared to the other costs of deploying.
So perhaps maybe on the CDN side, I think the RTP streaming is traditionally via a pump or something that just kind of pumps it out.
Yeah, it might
as
depend a
opposed
little
to
bit on where, I mean, if you were to say, hey, in the future I want to use MBMS to deliver video that comes from a wider variety of sources, the ability to ingest into and view that as a delivery service, then maybe if it could essentially hang off of a CDN and become a delivery mechanism, then that might be a place where you could create some leverage.
Okay.
I just wanted to add that I think to normalize on one kind of a workflow for multiple endpoints, it makes a lot of sense. And so, M-ABR is with Dash is evolving as that standard, and so then, that would be very beneficial even on the prep side in terms of cost.
Right. So is there really anything that operators need to put on their client, their players, their handsets to support multicast, and whether it's multicast ABR or eMBMS, but generally, is it agnostic? Is it?
Well, I think they would need for handsets that need to be multicast endpoints. Obviously, they need to have the ability to join a stream, and so that would be a requirement. And even in the case of ABMS, there is some middleware that needs to get loaded. And but on the other hand, if you were using it just for distribution inside your network, and you're actually going to access it through Unicast, then it should be transparent to that. So.
And the Comcast architecture sort of has that agnosticism, right? It's
right. The multicast terminates at the cable modem, so all the devices behind the cable modem are completely unaware that the delivery of that content has been fulfilled by multicast.
Okay, perfect. At this time, I'm going to continue with questions, but I'm going to open up the floor to questions as well, so we can keep that interactive. Yeah, go ahead. So the question was, Parisa, can you put some use cases together for multicast outside of the, stadium?
Outside of the stadium. I'll tell you about what we have launched so far commercially. IndyCar is one app that Verizon owns and sponsors which is only inside the racetrack. Which previously, due to network congestions, live video was not, allowed inside the track. So through Multicast, we are offering unique, video streams only for folks that are inside the track due to content rights. But also, we're using it, for example, I'm sure some of you are aware of Verizon has launched this millennial app, Go90, that does a lot of short form content. At the same time, a lot of concert sports such as NBA, NFL. So Go90 is nationwide, and we're using Go90. Also, there's multicast integrated, Lte Multicast integrated inside Go90. So any of the live events and concerts they have is also available in Lte Multicast. But outside of the B2C example, we also looking into the B2B examples, such as software delivery to telematics to the cars. That's a huge pain point for the dealers, and the range of the cost to the dealer and the friction point to the consumer is high. If the car is connected with an LTE chipset and has the right middleware in it, that software can be pushed overnight to the car. The other use cases we're looking into is also digital signage. Digital boards with the LTE chipset and the right middleware in it can receive either live digital signage or cache content overnight. And it also solves the friction of a technician or a landline to push the data to that board, and the frequency of the change in, that you want to change the ad or the live stream. So we have actually demonstrated these use cases at CTIA and at CES earlier last year. But those are some of the use cases that we're going after as well. We don't only see it as a B2C play, but also we think there's a lot of cost efficiency and resolving friction point for the consumer on the B2B side.
Perfect. And that's a good segue into my next question, which is, what are some of the other applications for multicast? So we know, video, there's audio streaming, software, firmware images, these sort of things. Can you see other perhaps clever ways that we can use multicast to hit a larger audience with a service?
From the wireless side?
Wireless, wireline.
Yeah, I mean, as I mentioned, from the wireless side, again, it just enables a lot of use cases that traditionally people have stayed away from because of the cost either to the business or to the consumer. So we're just analyzing all of those and see at what point it becomes beneficial to take away from the valuable spectrum. It's a balance, it's a business decision. Is it worth pushing it still on Unicast or look into multicast and how it enables at a larger scale, but a most cost-efficient way to deliver that content, which could be in the form of a video or a software update or digital signage.
Okay. So things like push VOD or preloaded ads, these sort of things when you're doing targeted advertising.
Exactly, cache content, large volume. You can get up in the morning and the latest USA Today could be already loaded into your handset, without, quickly, fast, and without, going too much against your consumption.
Excellent, excellent. So how about content protection? I know that you'd brought up that there were rights issues with doing these the in-car stuff, and do you have to protect that content? And if so, how are you protecting that vis-a-vis multicast?
So multicast uses a dash, the dash protocol. That's part of the 3GPP. So dash in itself has a certain layer of security in it. Also there has to be a handshake between the app, the middleware, the device, for that content to display on the mobile device. So all these handshakes and all these verifications is, it's against any risk of piracy. And of course, the player can always, the application or the player that the content provider or the end user develops can always has its own, DRM to do the protection. Right. So there are several layers, and also, it's going through Verizon's private LTE network, which is going through its own scrutiny of content protection and any kind of data protection for the consumer.
Right.
So when you add these several layers to it, it just becomes quite difficult to be able to hack that content or just,
True.
I just wanted to add to that, the multicast can ultimately enable an evolution of DRM to take the role of even a conditional access, with key rotation and so on. So it opens up a lot of interesting possibilities, which will allow you to do then easier, like time-shifted viewing or network DVR without having to have this enormous re-encryption and all these things that currently are in place. So.
Okay. So it can facilitate a transition away from CAS onto DRM-only platforms. Excellent. And Kobe, how are you handling DRM within the context of this? Is there any
Yeah, exactly the same way that we handle DRM for our CDN. Thinking of the caches in the gateways as somewhat of an extension of our CDN. If the content's protected well enough to sit on our public CDN, it's protected well enough to sit inside the gateway device.
Okay. And are you looking to multicast manifest files as well, or is it just segments?
The size of manifest is so small that the complexity of multicasting them isn't worth it. So we're just multicasting video segments.
Okay, perfect. Yep, back there.
We are currently in an enterprise environment, multicasting Windows Media internally and doing adaptive bit rates using standards like HLS and smooth stream outside of our network. It sounds like you guys have proprietary multicast controllers and middleware on the edges and stuff to determine which stream you're actually receiving. It's not a true adaptive bit rate standard. So how can the rest of us actually multicast an adaptive bit rate?
I can actually flag that one. So there's actually nothing really proprietary here. There's two standards which are actually on a convergence path right now, which is the EMBMS work for doing streaming of Dash, and the CableLabs specifications for Multicast ABR. So I represent that team within CableLabs, and I'm working with Dash IF as well as the forums in Europe and SCTE and Etsy to be able to take what we've done in the specification development and move that into it's in the public space now, and move that into an actual standard as opposed to a specification. So that spec, we have some discussions with the Streaming Video Alliance. We have some activities with Dash IF to come up with a single standard for multicasting segmented video. And Ericsson is actually in Europe heavily involved because those are the teams that had worked on EMBMS before and looking to support this type of architecture within the next version of EMBMS. So it's on a pretty good convergence path, and whether you operate a wireless network or a wireline network, we hope to have one standard. We just have to figure out which forum is going to manage that standard right now. So, and there was a question over here.
So with the stadium experience for EMBMS with mobile devices, the multicast is just one way. It doesn't seem like the client can request a change in the bit rate for video, for example. So I'm trying to understand how the ABR fits with the multicast in this situation.
Okay, so repeating the question is, multicast is one way. How does the client get other content into multicast? How does it shift bit rates? And anyone could answer this on the panel.
So in our case, Lte Multicast is a guaranteed bit rate. So I dedicate a pipe during those 2 hours of the game. I'm guaranteeing you that you're going to get 1 megabit per second content. So yeah, it's a broadcast. It's just one way, and I'm guarantee you're going to get it at the best quality, whatever we choose to push the rate within that pipe.
I view it as a managed delivery service. So in a wireline network, you would probably just put the highest bit rate into the multicast. You could put multiple bit rates in there if you wanted to, but if I get the highest bit rate to an edge node that's inside your home, then the likelihood that the client is going to request a lower bit rate is pretty small.
Yep.
Inside the home.
And even for the CableLabs spec, it's open enough that we still have the adaptive elements. So you may stream the highest bit rate you have available, or maybe the top 2 bit rates, and your manifest stipulates you can only retrieve that top bit rate. But there's a Unicast failback mechanism within this architecture that allows you to, if you wanted to, put in whatever number of bit rates you want. Most likely you're going to get those higher bit rates, but if they're not QoS assigned, using diffserv or something similar, then you still have the ability to step down. It's just going to be in a Unicast fashion. And that can help you a little bit on channel changes and these sort of things where something may not already be in multicast. But I did want to ask this question, which is, the Verizon implementation is a multicast broadcast, always on. It's always there, Igmp join, and you're getting that content. I'd just like Kobe to explain a little bit the dynamic multicast element, which is, on-demand type multicast.
Sure, yeah, we're relying on basically a voting algorithm to pick the most popular channels in real time so that we can make computations on which channels to switch to multicast, realize the most network gain. So there is a period of time when the cable modem would first boot up and have to inspect the traffic for a certain amount of time to be able to cast a vote. And then when those votes are counted on the server side is when decisions on what's going to be multicast are made.
Great. I did see a question over here. I don't know if it got answered. You gave up? Mm-hmm. Okay. Over here?
Just to follow up on that, I'm curious about the overhead or the cost of the switch from unicast to multicast, because theoretically, if you had even two people requesting the same stream, you could flip the multicast and save the bandwidth associated with one stream. So are there other overhead costs, or why wouldn't you just, any vote equals two, flip the multicast?
Yeah, so there is a cost to setting up the Igmp channels, and so we need to a certain extent dampen the frequency of changes, and that's the main reason.
Is there a limited number of UDP, multicast channels, or is there like a CPU cost? What is the cost?
Yeah, so part of the challenge for us to maintain quality of service for the multicast channels is to pre-provision a certain slice of the network for multicast, and so whether that's and that's one of these knobs that we're still trying to figure out, whether it's going to be 50 channels in a market or 100 channels in a market. So.
Over here?
I got confused too. What is your strategy? Can you see that most of the traffic, I know the traffic is moving from HTTP to HTTPS, and intercepting HTTPS queries through the cable modem. I'm not sure how that happens. And so what is exactly around that?
Yeah, that's actually going to be a challenge for us. So today, all of our video content is HTTP, but as we move to being compliant with Dash EME, HTTPS delivery is something that we're going to have to figure out on the cable modem if we're going to continue to use this strategy. It's not a simple approach, but using the same certificates that we push on the CDN edge nodes could be delivered to the clients. It's not necessarily an easy feat, but technically feasible.
And one more question.
For Kirby, have you solved for EAS and the storm of multicast traffic that would be required for the transition?
So our voting algorithm isn't really fast enough to solve EAS. So we've already we already scale the network to do unicast EAS delivery. I could see an optimization in the future where we leverage perhaps a pinned up multicast channel to deliver EAS, but that's not something we've built yet.
Okay. And I'm going to conclude really with one last question because we're running out of time. Longevity for multicast. I've heard many people say, well, multicast is a temporary fix. It's going to get us through a little bit of a storm while the world becomes all unicast. But with the advent of 4K, 8K, 360 video, and even heavier virtual reality streams and these sort of things, do you see longevity in using multicast, or is it something that we're going to use temporarily to pin up our solution? And I'll ask that of anybody on the panel.
I think bandwidth is always going to be at a premium, especially in the last mile, and that's not getting solved instantly with any technology that I've seen so far. So that there will always be an issue there. And furthermore, as you pointed out, with higher resolutions and the fact that you can't really easily handle traffic distribution in the core, you still need some ability to do both and have a judicious mix of the two going forwards.
Right.
Again, I think it comes down to usage patterns. As long as linear remains a significant portion of the access network bandwidth, multicast has a place.
For us, it's the way of the future. In order to have it sustainable in providing quality service, video usage, as the usage increases in the network and limited spectrum, we have to be using these creative ways to maintain the network as well as satisfy the customer. And nirvana for us would be the dynamic allocation of multicast versus unicast. And once we reach that point, that's the way to go.
As Kobe said, it's really driven by consumer behavior. So if you can forecast when consumers will stop watching TV at the same time, then there's your end date.
Excellent, excellent. All right, well, I'd like to thank the panel. I'd like to thank everybody here for attending today, and hope you have a good rest of your day. Thank you.